All right, today we're pulling back the curtain on something you use literally every single day, your apps. We're going to dive into the two main blueprints engineers use to build them, the classic all-in-one monolith and the super flexible modern microservices.
Seriously, have you ever stopped to think about it? You tap an icon on your phone and boom, a whole world just opens up. But behind that super slick experience, there's this intricate structure, a plan. And trust me, that plan is everything.
So what is that plan called? It's called software architecture. The easiest way to think about it is like the master blueprint for a massive skyscraper, right? You wouldn't just start laying bricks. You've got to know where the walls go, where the plumbing connects, how the whole thing is going to stand up. Well, software, it's the exact same deal.
Okay, first up, let's talk about the classic blueprint, the OG way of building software, the monolith. And honestly, the name kind of gives it away. It's all about building one giant single block of code.
The whole idea here is that everything is just together. The front end, the stuff you actually see and interact with. The back end, which is like the brains of the operation, and the database. It's all just one single code base. They're all tightly woven together, living and breathing as one big single unit. Okay, let's make this concrete. Imagine a college app. In a monolith world, the student login, the portal for the faculty, the attendance tracker, all of those things are just different parts of the same program. Think of it like they're all just different rooms in the same house. They're totally interconnected, and they all depend on each other to work.
And look, for a really long time, this was the way to do it. And for good reason. It's pretty straightforward. It's way simpler to develop and test in the beginning because, well, everything's in one spot. You can get a new app up and running super fast, and it's much easier for a developer to wrap their head around the entire system.
But here's where the problems start. As that app gets bigger and more complex, you start to see these cracks in the foundation. You want to fix a tiny little typo on a button? Guess what? You have to redeploy the entire application. And what if one small piece breaks? Let's say the attendance tracker crashes. Well, that can bring the whole thing down. Student logins, faculty logins, poof, they're gone too. You can see how this becomes a massive headache for big, complicated apps.
And that is what led to the modern approach, an idea born to handle all that complexity and scale. Let's talk about microservices. Here, instead of one giant block, the whole philosophy is to build your app from a bunch of tiny, independent pieces.
Yeah, this really sums it up perfectly. A monolith? It's like one big, tightly woven piece of fabric. But microservices, they're more like a set of Lego blocks. Each block is basically its own tiny little application that does one specific job. And they all talk to each other, but they do it over a network, using something called APIs.
So let's jump back to that college app. In a microservices world, the student login is its own little app. The faculty login? That's another one. The attendance tracker? Yep, a third one. Each one runs completely on its own, with its own code, maybe even its own separate database. They communicate, sure, but they don't need each other to actually run.
And this is where you really see the power of this idea. If the attendance service goes down, no big deal. Students and faculty can still log in just fine. Need to push an update to just a login page? You only have to deploy that one tiny service. It's so much faster. The whole system just becomes way more resilient, way more flexible.
All right, so we've got two totally different blueprints here. Now, it's super important to understand that one isn't just better than the other. They're different tools for different jobs. So let's actually put them side by side in a showdown. Okay, let's break down the trade-offs, because that's really what this is all about. With a monolith, things are pretty simple at the start. Great for a small team, a new project, but you pay for that simplicity down the road with slower updates and a real pain when you try to scale up. Microservices, on the other hand, are way more complex up front. I mean, you're suddenly managing this whole distributed system, you're worrying about networks, but the payoff is huge. Amazing flexibility, much easier scaling, and incredible fault tolerance. Like we said, if one piece breaks, the rest of the app just keeps on chugging.
So, with all these trade-offs, how on earth does an architect actually make the right call? Well, it's not just about picking a side. They rely on a set of guiding principles, sort of these timeless rules of thumb that help them build really strong, resilient systems, no matter which blueprint they end up using. Let's dig into what those are.
First, you've got the core design principles. These are the big ideas. Number one is modularity. You gotta break things into smaller, independent parts. Even inside a monolith, if you design it with distinct modules, it's way easier to manage, and maybe, just maybe, break it out into microservices one day. Then there's scalability. You have to plan for success from the get-go. What happens when you suddenly have 1 million users? Microservices are great for this because you can scale up just the busy parts. But any app needs a plan for growth. And finally, resilience. You've got to build systems that can get punched in the face and not fall over. It's about handling failure gracefully, which is a superpower of microservices, but something every architect aims for.
Okay, next up is what we call operational excellence. This is all about how you actually run the thing day to day. A huge piece of this is automation. You automate everything you can to cut down on human mistakes. You also set up something called CI/CD pipelines. Think of these as automated assembly lines for your code that help you test and release small updates all the time, which is absolutely essential when you're juggling a ton of microservices. Of course, you need monitoring and logging to see what's happening and catch problems early. And a massive one these days is containerization, using tools like Docker. This basically puts each service in its own neat little box so it runs the exact same way everywhere.
And last but not least, you have to think about the people and the process. Security has to be baked in from the very beginning, not just tacked on at the end. This is so critical when you have all these little services talking to each other. Then there's infrastructure as code, which is a fancy way of saying you manage your servers and networks using code, making everything repeatable and reliable. But you know what might be the most important? Creating strong feedback loops. Communication is just key. It's how you make sure you're actually building the right thing for your users.
And I think this quote really nails it. These aren't like strict, unbreakable laws. They're more like practical, battle-tested suggestions that help architects make good decisions and build better, more reliable systems.
Which brings us to probably the single most important point of this whole thing. There's no single best architecture. There's no magic bullet. If you're building a simple app, a monolith might be absolutely perfect. If you're building a huge, global platform, yeah, you're probably going to need microservices. The real art of being a software architect is knowing which blueprint to choose for the job at hand.
So where do we go from here? Technology is always changing, right? We started with the beautiful simplicity of the monolith. Then we evolved to the incredible scale of microservices to solve new problems. It really makes you wonder, what challenges are coming next? What will the next generation of apps demand from us? And what will that next great blueprint even look like?